Rizal, I'm not sure. My slides show.
Hi, Mpo. Can you repeat that, please, sir?
I'm saying I'm not sure if you can see my slides.
I can see your slide. It's still in presenter view mode. So maybe
Okay.
Godfrey and team, if you can assist in just helping me share my screen. Thank you. All right. If everyone can see my screen and hear me properly, I am ready to start. Welcome, everyone. Good afternoon and welcome. It's been fantastic to see so many of you joining us today for the World Engineering Day webinar. I'm Marisol Pinar, the CESA YPF National Vice Chairperson and a civil engineer at Biggin. I'm working in the water sector and I'll be facilitating this exciting session today. Today is World Engineering Day for Sustainable Development. It's celebrated annually on March 4th, and this day highlights the crucial role engineering plays in achieving the United Nations Sustainable Development Goals. This year's theme is Shaping Our Sustainable Future Through Engineering. The main event is being held at UNESCO's main offices in Paris, featuring keynotes, panels, and discussions from leading figures in government, science, and entrepreneurship. It's exciting to be part of this global celebration and contribute to the conversation about how engineering can help create a more sustainable world. We'll be diving deep into the upgrade of the Zandvliet Wastewater Treatment Works, a project that's not only transformed the wastewater treatment in Cape Town, but has also made a significant contribution to the environmental sustainability, social equity, and economic development. But before we delve into the details of this incredible project, let's take a moment to acknowledge the organization that has made this webinar possible. Firstly, a big thank you to CESA, the Consulting Engineers of South Africa, for their dedication to promoting engineering excellence and sustainability in our country. CESA plays a vital role in fostering collaboration, knowledge, and sharing, and innovation within the engineering sector. And speaking of excellence, we can't forget to mention the prestigious CESA Aon Engineering Excellence Awards, which recognize outstanding achievements in the field of engineering. These awards celebrate ingenuity, creativity, and dedication of engineers who are pushing the boundaries of innovation, making a real difference in the world. In fact, the Zandvliet Wastewater Treatment Works upgrade that we'll be discussing today is a proud winner of the 2024 CESA Aon Engineering Excellence Award in the mega project over 1 billion rand category. This is a testament to the project's exceptional engineering, its significant impact, and its contribution to sustainable development. Next up, I would also like to take the opportunity to just talk about the Young Professionals Forum, as you know that I'm part of that. So in short, it's called the YPF, and it's a dynamic platform that empowers and supports young engineers in their professional development. The YPF is committed to nurturing the next generation of engineering leaders, providing them with opportunities to connect, to learn, and to grow. Our objectives include fostering mentorship, promoting skills development, and advocating for the interests of young engineers in the industry. Of course, none of this would be possible without our generous support of our YPF sponsors. So we extend our sincere gratitude to each and every one of them for their commitment to investing in the future of engineering. Now, without further ado, let me introduce you to our esteemed speaker, Mpho Rampo. Mpho, I'll give you a chance to start sharing your screen while I introduce you. Right. So Mpho is Managing Director of Zutari's Water Business Unit, where he's responsible for overseeing a team of around 300 professionals, driving organizational vision, strategy, financial sustainability, and commercial health of the business. He holds an MSc and BSc in civil engineering, both from the University of Cape Town, and is a member of CESA and WISA. In 2011, he was awarded the CESA Aon Young Engineer of the Year. He is a water treatment specialist with extensive experience in water and wastewater treatment infrastructure spanning over 20 years. He has conducted research into biological wastewater treatment, authored and co-authored at least 10 scientific papers, and presented at international conferences. From 2010 to 2021, he was an external examiner and postgraduate guest lecturer at the University of Cape Town. Mpho has led major engineering projects in South Africa, Namibia, and Australia, collaborating with clients, stakeholders, and leading multidisciplinary teams. Mpho's contributions in the water engineering industry have significantly advanced South Africa's reputation in wastewater treatment technology. Over to you, Mpho.
Thank you very much. I'm just going to check. Is my sound clear now?
Yes, thank you.
Okay, all right, thanks very much. I was trying to use the background that was provided to me, but unfortunately it showed me very far away, so I've just resorted to just a normal background. So apologies for that. Welcome everyone. It's really great to be on this platform to just talk engineering and everything that revolves around engineering. And it is my pleasure to try and wow you on this wastewater treatment project. For now, let's call it a wastewater treatment project. But for me, it goes beyond that. It's something that I think it's a vocation. It's really a calling for me. So without further ado, let me just maybe start by saying the Zandvliet Wastewater Treatment Works, it's a strategic component of the City of Cape Town's wastewater treatment management system. And long before we even got going on the project, it was under capacity and it needed to accommodate, as you know, the current and the future loads envisaged for that part of the catchment. Also, it is important to note that Zandvliet is actually the third largest wastewater treatment works after Athlone and Cape Flats for the City of Cape Town. It treats wastewater from a population equivalent of about 600,000 people living in the southeast of Cape Town metropolitan area. And for those that may not be aware where this is, I'll show you on the map where this is, but it's predominantly wastewater flows from Delft, Blue Downs, Khayelitsha, and some parts of the Cape Flats, which falls within that southeast area. In 2006, in an effort to try and deal with the pressures, and I'll explain what those pressures are, because it's not just wastewater, it's also socioeconomic factors. But in 2006, the treatment plant actually received in excess of about 100 megaliters a day. However, the existing plant that was there could only deal with about 64 MLD, and hence the need why the city was trying to upgrade the plant. In all fairness, the City of Cape Town did go out to tender 4 years prior to 2013, 2014, which is when we got involved. But there have been challenges around court cases and appeals, land claims, and the likes. You know, there's also a sand mining company there that has got mining rights to mine around that treatment plant. And the background picture that you see there actually shows some of the sand dunes that have been mined with the False Bay or the ocean in the background. I'll try and take you through that. But the city tasked us to come up with a wastewater treatment plant that will reliably, under all operating scenarios, treat the current load of 100 MLD in a manner that will comply with the stipulated discharge standards from the Department of Water Affairs. Now, we actually got going in 2013 to respond, amongst other things, to the current challenges and also to the rapid growth in that catchment area of the southeast of Cape Town, and also to tackle some of the constraints that were experienced at the wastewater treatment plant. And these challenges actually exacerbated the situation, which was a significant pollution and degradation of the downstream Kales River, Easter River, estuary and estuary ecosystem. Some people might that know the part of the where the wastewater treatment plant is might wonder why treat and deal with this plant's effluent to such a standard if you're just gonna be discharging into the ocean, which is about 4 kilometers from where the wastewater treatment works is. So the background that you see, the actual discharge point is about 4 kilometers from the wastewater treatment plant. And I'll try and deal with that question in the presentation. However,
apologies, Simple. I don't know, are you moving your slide?
No, not yet. So
okay, thank you.
I'm gonna come to that. I'm just giving the background. To try and slow down the pollution in the river system, which was so bad, the government actually introduced a moratorium on development in that southeast node of the city of Cape Town metropolitan area, leaving thousands of poorest communities and citizens without adequate housing and proper sanitation. So you can imagine the socioeconomic pressures and problems that come with it. So the project from our side involved a multidisciplinary team comprising at least 180 technical staff from all walks of life, Zutari's business, which comprises of all multidisciplinary engineering and advisory services. We were all tasked with this project. It involved about 8 contracts working in parallel on top of each other on site. And we had at least four Zutari site teams to ensure that the plant continues to operate while we are upgrading the plant, which is a complete demolishing of the wastewater treatment plant. So now to just try and give you a sense, I'm gonna just go through some of the wastewater treatment fundamentals and our approach in dealing with the situation at hand, which was more of a socioeconomic situation rather than a wastewater treatment problem alone. And then I'll touch a little bit about what you want to hear, which is the actual wastewater treatment plant at Zandvliet and the solution that we came up with, and also why we think we've provided such an impact that has never been seen before in such an engineering project. So for those that maybe are wondering, so that is actually the informal settlement adjacent to the wastewater treatment works. So to try and deal with this issue, I want you to think about trying to provide an engineering solution, specifically sanitation and other urban services in such a situation where it's informal. How do you actually deal with it? A rapidly expanding situation. The other piece of information to help you frame the challenges, this part of the area where the city of Cape Town's plant is located, it's one of the poorest. And in terms of water, sanitation, solid waste, and even electricity, it's got the lowest of all the available infrastructure that you can find around the metropolitan area of the city of Cape Town. So these are some of the challenges that we had to deal with. You can see protest. You've probably heard about what was termed the poo throwers, which became a political situation in the city of Cape Town. You can see a part of the Easter River, tributary there on the other side with animals grazing and probably drinking the water. So the question is, what should the sanitation for a place that is plagued like this, that is so highly densified, how do you come up with a solution for that? And how do you sewer such a complicated system? And when will the actual solution be online that satisfy the forever changing goalpost of this informal settlement mushrooming? So I framed this with an exam question that moves away from a wastewater treatment plant. And I called it, how should a rapidly urbanizing African city it could have been any city in the world, deal with our wastewater while addressing socioeconomic challenges. And in the background there, just to break from the city of Cape Town, I've just showed, for those that are familiar with our country's landscape, that's basically Johannesburg. So it could have been applicable in a city like that as well. But first, let's start with the wastewater fundamentals. So is it okay if I move, this screen here is disturbing me. I just want to minimize that so I don't see my face. Okay, great. So for you to understand, to be able to provide a solution that is sustainable to address some of the challenges of sustainability, you need to first understand where water comes from, or what we call the water cycle. You also need to understand that we've got an infinite amount of water on this planet. So there's no new water that has been created. So we have to be good steward of what has been entrusted to us. So in order to illustrate that, so let's first look at what are the objectives of a wastewater treatment plant. On the left there, it's the same environment that can happen anywhere in the world. So I'm showing Accra, Ghana there, where we've done some projects as well. So that picture was taken from there. You can see what's happening in the river. We don't want those pollutants in the river. The middle picture, actually, it's the background there is the ocean, and on the opposite side is actually the Lagoon Beach Hotel, for those that know Cape Town. So that pollution that you see there, it's actually the river mouth coming from one of the wastewater treatment works from the city of Cape Town that is currently under the upgrading. So you can see the same challenges we have in Durban as well. So it happens in the city of Cape Town. So don't believe whatever the politicians are telling you. So that's the real picture. And I used to go there quite a lot when I lived in Cape Town with my kids playing on the beach there, playing soccer. It wasn't like that. So it took literally 3 years to become what you see right there. And on the right, it's actually a vegetable garden near the Zandvliet Wastewater Treatment Works in Philippi that is thriving. So, and there's a reason why I'm showing you all of this, to say if we are being good steward of our water resources, you also need to understand that the biosolids, or even that effluent, if it's treated to such a quality standard, it can be used for food security. Now that you know that there's a lot of pollutants, but I bet you didn't really understand that in the wastewater, it's actually 99% water. The rest is pollutants that we don't want. So all of these stuff that we're dealing with, we're trying to get that about 1% of pollutants and nutrients that we don't want in our water courses, our water environment, so that we can be good steward of this finite resource. Actually, water, when it's treated to the right standard, there is no quenching drink that you can ever find anywhere in the world that it's a source of minerals and vitamins. So we really need to look after this precious resource that we have. And some of us have got the calling to actually get our hands dirty in what other people might think it's a waste, whereas we see it as a resource. Now, having said that, how do we go about removing these pollutants in the wastewater treatment plants, in the formal treatment plants? Firstly, obviously, we have to deal with screening and making sure that we remove all the debris that it's in the wastewater treatment works. But the ultimate goal is to remove these pollutants. And the way we do this is we create conducive environment. And in South Africa, I have to add, we've been at the forefront of what we call biological wastewater treatment in the form of activated sludge processes. What that means is it's a culture of bugs that we create, like bacteria that we create under different conditions to actually help us degrade these harmful pollutants in the wastewater. We can either do that in a conventional manner, which takes up a lot of space, and I've got examples of that for this project. And then we disinfect the water to make sure that it's not harmful for downstream environment. Or you can take one step further and do it in a most advanced way. And there are various ways of using advanced treatment. The one that I'm going to be focusing on today is called membrane bioreactors, which is a technology that has been integrated with the conventional system at Zandvliet. And I will try and explain why also down the line, why we've chosen that technology. So other than that, these are the fundamentals. So in Zutari, we've got a guiding principle when we look at problems. And that's why I spent about 5 minutes explaining that it's not just a wastewater problem that we see. We see other socioeconomic factors, and that's why I said, what is the real exam question? So in Zutari, we've got these 6 impact themes that we'd like to see in every engineering project that we touch. And if I have to start and go anti-clockwise, going clockwise, starting with enabling responsible production. What does that mean to us? For us, it means that whatever we do must be sustainable for generations. It's not a once-off thing, which is why we took our time to understand what I call the unarticulated challenges facing the city of Cape Town. To them, initially, they thought they're dealing with just providing capacity for a wastewater treatment plant so that the moratorium on development can be uplifted and probably for them to get rates and high taxes from businesses that would be mushroom on the southeast of that part of the world. But for us, it was more than that. It was addressing socioeconomic part and also dealing with, what I call responsible production. And I will touch on some of these things, why we call these just a resource factory rather than a wastewater treatment plant. We also needed to deliver what is called resilient places for people to interact with the place and for the solution that we provide to still be there for generations to come. And also we needed to make sure that it's adaptable. And I'll explain the adaptability that we went through maybe in one of the process trains at Zandvliet. And remember, our mandate was to make sure that the plant can operate under all operating conditions that that plant was facing. And the other one was to just make sure that we accelerate what we call equitable quality of life. That's why the socioeconomic aspect of it comes in, the plant operators, how they interact with the plant so that they can be good steward of that treatment plant also came in, which meant we actually had to provide an infrastructure that it's not seen as inferior for people to actually work. And the other thing is obviously to provide digital worlds, meaning we need to come up with a way that we can integrate digital smarts in the solution that we provide. And lastly, shaping radical collaborative networks for the operators to be able to interact with the plant in a manner that it's conducive for sustainability, and in a manner that the plant responds to them and they respond to the plant. So having said that, this some of the early days with the construction pictures in the background, just to show you what was happening. So this is the picture of the locality plan that I said I will show. So this is the False Bay on the background. You can see those communities, Kailicha, Blue Downs, Mfuleni, Delft, Philippi. There's farms there, the Philippi farm that I was talking about. You can see it there. But there was also a lot of work that took place outside the actual periphery of the site in preparation for these, to make sure that all these catchments drain their wastewater to this treatment plant before it's been discharged into the environment. Obviously, we can't do this as Zutari alone. So we were the designers and the advisors for the city of Cape Town. But I'd like first to acknowledge the operators of the plant that have been employed by the city of Cape Town, WSSA, and most importantly, the contractors that made our little sketches and diagrams a reality. So that was Steph Stocks, or in English from the civil side. And on the mechanical and electrical side, it was PCI Africa, largely based in Johannesburg, and Inenzo Water, who are Cape Town-based company, and also the technology suppliers Suez, they are now called Veolia because they've been taken over by Veolia, and also Caltron, who were the electrical contractors on site. So this just to show you the early days. So this project involved keeping a plant that was dysfunctional working, and at the same time coming up with critical infrastructure to alleviate that bottleneck on the wastewater treatment works. And in the background there, you see the scale and the magnitude of what was done. So those pipelines that you see on the right-hand side, those two pipelines, they're actually 1.8 meters in diameter, just to give you a feel of the scale. So they are very big. So, I mean, I'm not 1.8 tall. I remember walking in one of those pipelines, obviously in a responsible manner with gas monitors to just make sure that harmful gases do not overcome me. So even if it's a new pipeline. So that's just the sheer scale of what was happening. So the plant itself, apologies, I don't want to use the pointer because I had finger trouble when I was checking if the presentation works. So I'm assuming you'll be able to see. So the big cycles, if I can just use maybe my mouse, yeah, so that's the conventional activated sludge system, which is basically a biological reactor with these things called settling tanks. So in here, we create conditions conducive for degrading the pollutants in there, but we have to settle the particles to make sure that they don't go into the river environment. So we use these big tanks where under gravity, the heavier solids actually settle to the bottom and the clear water overflows what we call the channels or the launder channels of these circular tanks before we disinfect it in this chlorination contact tanks. So that basically we just bubble chlorine gas and provide enough contact time so that it can kill the bugs. This is what we were, when we were appointed, we thought we had to deal with, which is this part of the plant. And just to explain the importance and the significance of that part of the plant, this plant alone is equivalent to all these things that you see here, all this big thing here, that plant alone. They have this one, which used the same technology as membranes, but it was also dysfunctional and would come out to basically the end of its lifespan for various reasons that I'll not go into the details. And I will show you what the actual solution looks like. All these infrastructure that you see here, all of this is all new. But to just explain, so there was a new inlet works, new primary sedimentation tanks, and we needed that for the future upgrade of the plant right here where you see the sand dunes and the vegetation that you see here, because there's actually going to be a biogas plant for converting the methane gas into power, what we call combined heat and power or cogeneration for some of those people that may be interested in the details. So we had to provide this so that we can get the primary sludge, which is a source of high energy in wastewater, and then put it in the digesters. And if I just carry on, like I said, that part of the diagrams denoted case A and case B, it's actually the same size as the one called MBRB on that side. So you can imagine already, you can see the sheer scale and the engineering ingenuity that came into play to try and deal with the situation there where there is no land. You can see there's no land. It's surrounded by sand dunes and mining issues and mushrooming settlements on the left of the screen. I don't think this is important. So just to give the real scale, you can see it now, what it looks like. So I just want to maybe touch on a few issues that most people think to deliver a project like this smooth sailing. Firstly, this was what I call the war room. I had a few key people in this room, so we're probably about 15 in total. Yes, 15, doing different things on the plant. I also decided to stay away from chairing these meetings, but every single person was given an opportunity to raise what the issues were, and those issues were written on the board there in different colors of their choosing. And this meeting didn't have a set agenda. We called it a free-for-all, for the lack of a better word, meaning you can come here and raise issues in 45 minutes, and we go and deal with those issues to try and make sure that we don't fall behind on issues on site and what issues needed to be resolved. So, but one of the things that I also want to highlight here is the project was plagued by many issues. We had land claims, as I said, which delayed the project by about 2 years. Just when we thought the land claim was over, there is a company adjacent to the plant that is actually mining on the existing F of the wastewater treatment works. Just when you think it's easy to tell them to stop mining because you need to upgrade the plant, it was an issue because they had mining rights that extended up until 2025. And there was no way that we can wait till 2025 with a hot situation in terms of socioeconomic and pollution in the environment. So we had to compromise. But there was a delay of 2 years, court cases and a few things. What that did is it actually increased the cost of the project in terms of the escalation. Firstly, the local escalation, which is the inflation related to construction and labor matters. But the bigger chunk of that was related to what I call the foreign part of the exchange variation, because most of the equipment that we provide here are all imported, and that was a hefty price tag to pay. So just in passing, maybe to know that. So the final solution, it's what you see. And here on the left, it's basically what we call the sludge dewatering plant. It's where we harvest all the biosolids, concentrate them to solids, and then the clear water, again, a valuable resource, it's returned back into the plant, and the solids, complying to a certain stringent standard, we either dispose that to a landfill site or it gets carted away for landfill applications and also for agriculture, like the ones that I've shown you. But in future, none of those solids will be leaving this plant because it will be used in the cogeneration that I spoke about, where where the City of Cape Town's plan is actually to convert all these biosolids into electricity in the form of combined heat and power. And our initial simulation shows that half of the energy that this plant consumes, at least half, will be coming from this plant. It's as high as 75%, but reliably we are sitting at a figure of about 62%, almost just under 2/3 of that. And that biogeneration plant will be on this part of the St. June that I explained earlier. So this channel that you see, actually, I'll show you a bigger picture of how it looks like. It's where the water actually leaves this plant into the river before it gets into the environment. You can already see what's happened with the sand dunes in the background, the mining that is taking place. So the big plant that we thought were only asked to do, it's the one that you see in the background and the equipment that goes with it. And this is essentially how it looks like. I want to just spend maybe 2 minutes on this plant. And for those that like technical aspect of it, I'm more than happy to share everything after the meeting. But what it is, this plant is designed with so many redundancies that it can comply with all those operating scenarios to make sure that the plant meets the needs of the varying loads and changing flows in that catchment. Remember, one part that I said was the rest of the conventional plant had issues, even when we've upgraded those issues, but it's got its own limitation. Sometimes we deal with big loads, big flows, big nutrient load. So we needed a plant that can respond within reason to deal with those, to make sure that the effluent that is discharged into the environment still complies with in fact, it's more than what the discharge standard asks for. For example, one of the requirements on this is the nitrate discharge that's sitting at 6. I mean, it's a wastewater going into the environment, into the ocean, you may ask, especially because the drinking water level, it's actually 11 milligrams per liter, but they've asked for 6 here. And I mean, that's just to mention a few. We had to deal with it. So this plant is designed with so many redundancies that you can switch between 2 operating modes. And for those that understand wastewater and activated sludge terminology, they will know about what is called the University of Cape Town process, or the commonly known the UCT process. Remember earlier on, I said this country has actually been in the forefront of wastewater development, and it's largely known the world over, which is what has given some of us a platform to work in Australia, the UK, and large parts of Southern Africa doing wastewater treatment stuff. We can also switch the process into what I call the MLE process. And the way we go about this, it's all integrated. And obviously we use technology that I'll come to later on to explain how that happens. But we can switch the flows to go into channels and reactors that we want within a split second, just like that. And we do that to deal with the loads that are coming there, because sometimes they vary quite a lot. Like I said, it's a rapidly growing part of the city of Cape Town with different requirements. So that presented a challenge. So we deal with that through one single process. And we use this technology called membrane bioreactor. Earlier I showed why I showed 2 pictures, one for a conventional plant with what I call settling tanks to retain all the solids within the plant. But on that plant, the reason it's smaller is because we can use this technology called membranes, and the size of each one of the single element that you see there, it's physically the size of a spaghetti. So the spaghetti that you cook, one of those strands there is the size of that, and it's got a pore size or a filter size of about 0.05 microns. So most of the bacteria and viruses actually do not go through, but I mean, most of them don't. And obviously all the particles in the form of total suspended solids cannot actually go through any of that, through that pore size of 0.05 microns. You may wonder, do these things break? Yes, they do. And we've got technology monitoring each one of these things to make sure that if there's a breakage, before we can fix it, we know, we can see it, because we will see elevated levels of suspended solids and also turbidity rising in the plant. So this is one example of an old membrane that we had to deal with from the old plant. So we removed all of them actually and replaced them with the new ones to make sure that we can deal reliably with the loads. And on the right-hand side, you can see a new pump station. Some of us may ask, surely this comes at a cost. Yes, it's not for free, but we did look into the economics of it before we provided a solution that the city accepted. And the city's main drivers were also what I call the reuse, complete reuse of the effluent from this treatment plant, to make sure they can recover all of that and put it through a further advanced treatment plant for drinking purposes. And they're busy with that. And in conclusion, I'll touch a little bit on that. But this just shows some of the operating scenarios. You can see obviously a conventional plant, because it's simple, it's rudimentary, it costs less. But before you think it's less, you need to factor in the price of the land, which you don't have. And if you have to go and buy another land, it probably costs more. And you also need to factor the pristine effluent quality that you get, especially if your future scenario is to reclaim all of this water for drinking purposes. So the membrane bioreactor helped with that to avoid some of the pre-treatment steps that will be required for a reuse plant downstream. I've also shown the, just maybe for comparison purposes, what the cost show in terms of rands per cubic meter of water treated. So you can see it's much of a muchness, not that far off. And this is just some of the construction pictures and finished product. Earlier on, I spoke about the need for the plant operators to feel that they work in the office, just like any of us. In fact, this building is designed to be sustainable in such a manner that there's little maintenance required. So for you to understand this, you need to be on that side where you're constantly being bombarded by, southeaster winds with that sand dune in your face. It's quite harsh conditions. And for those that maybe are not familiar with the city of Cape Town, when the wind starts howling, you can hardly walk. And all you have to do is go to Google or YouTube and look for pictures, especially in the CBD, where people have to hold on to traffic lights so that they don't get blown by the wind. So that building, it's got everything. It's got boardrooms, just like in fact, much more beautiful than the one I'm sitting in now. It's got a lab, on-site lab. It's got, a VR room, and I'll explain actually what the virtual reality room is there for. It's got almost everything you can think of: proper offices, parkings, control room that you can see 270 view of the whole site, so that you don't have to actually move around the plant. You can control the whole plant from there. Actually, I can control the plant even from where I am right now today. I've got admin rights to the plant. So the virtual reality room that is in there basically came from some of the digital smarts that we employed in the project. And the sole purpose of those digital smarts was we designed this plant using 3D modeling in the form of Revit, and we use BIM as a platform to house our information so that different people from different offices in a company can interact with the design without the need to wait and see where the changes are. And we can log all the changes. You know what has happened and who did what. And if it's wrong, you can always go back and look at it. But all of that culminated into this 3D piece that we had. And in the picture there, it's me on the far right, and on the left, it's actually one of the contractor. He was a contracts manager for this portion of the membrane plant. So we took them there to show them how the plant looks like, because you can imagine there's too many clashes in a plant like this, but obviously the use of digital smarts helped us to avoid those clashes. You can see a 3D model on the right of pipework and pump station. So this is the contractor that helped actually to refine, even the plant further, because we showed them. And before this, we actually took the City of Cape Town maintenance team through the plant, and they also made the changes that they would like to see from a practical point of view. So they influenced the decision. But we wouldn't have been able to do that without the virtual reality that we employed on this project. And even with the several contractors, we were able to bring them into a virtual reality room and give them a headset and say this is how the plant will look like. And then they can go through it, and then we can do this in a more partnership model rather than the traditional 2D drawing. I don't think we would have even had the speed and the agility to respond to some of the tricky situations that we needed to deal with. In terms of insights, so this is the first plant that we've done that uses real life tracking and monitoring of what is happening on that plant. I can log in now, I can make changes, and it will respond. I can use the information to do predictive scenarios and advise the plant operators on site what they need to watch out for. So this is some of the stuff that we did, which is a live SCADA monitoring process that we've never done it before, live, like the way we've done it. So you normally go to site, and if things don't work out, you find out later. You have to go into the history and look at it. But this we can actually see. And this is so powerful that the plant energy and chemicals and all those operating scenarios that I mentioned about, we can actually do them on this platform to make sure that the plant never fails. We've got 4 different modules, as you saw in plant, 2 conventional plants, 2 membrane plants. So we can actually shift loads between all those plants depending on which plant we're trying to assist, the one that is maybe struggling with something, or maybe one of the electronic equipment is down, to be able to do that. And this inside tracking, it's actually quite important because the City of Cape Town has got what they call a digital support system, which they use to do those predictive scenarios during the day zero. Incidentally, for those that don't know, we actually developed that predictive scenario, Zutari, for them to predict when the water will actually run out of the city. And they use that to push out all the information that they were pushing out to the public. They are now in the process of integrating all this information together with the other plans that they're building for the City of Cape Town into their digital twin model for the water and wastewater treatment plants. So it's actually quite a powerful thing. While we were doing the upgrade, so we also took the opportunity, because we are involved downstream for the reuse plant that I spoke about. And if implemented in its totality, it would be the biggest direct, the keyword, direct potable reuse plant in the world. So most of the plant, they are bigger in terms of the flow that they treat, but they are not direct. So they're indirect. So they few of those. But this one, at a production level of 90 MLD, it would be the biggest direct reuse plant in the world. Which is why when we built that admin building, we needed to make sure that it can also be used for extracurricular activities and school excursion, to be able to train or bring to the fore the issues that we need to deal with for the youth that are interested in wastewater treatment plant or water treatment plant. And the virtual reality room that is there as well, it's there for the plant manager to be able to treat the new maintenance personnel that comes to the plant on how the plant works without actually physically going to the site. If you walk that site from one inlet works all the way to the effluent, you would have done 10,000 steps before you leave that site. So it's a huge site. So while we're still on the issue of the infrastructure that is there in the admin building, it was built for the sole purpose to make sure that we can showcase and host seminars and conferences at that plant without actually leaving the site. And for those that want to see how it looks like, they can go and look at it. The other thing that I want to highlight here is, while we were busy with the upgrade of the whole plant, we took the opportunity, since the water that will be used for the reuse plant will be coming from this very exempt plant. All of the water that we'll be reclaiming comes from this plant. At the moment, the plant, wastewater treatment plant, it's 100 MLD, but the city realized that they still need to upgrade the plant to deal with the actual loads that are coming to the plant. So the city is in the process now of planning the next 60 MLD plant, which is what is needed in the next 5 years to deal with the projected load on the site. And that will be a conventional plant, because the two membrane bioreactor plants together can give them a flow of 81 MLD. Even when that is pristine water quality, the new plant is also, the reuse plant is designed to accommodate the inferior water quality from the conventional activator sludge plant. There's pre-treatment that will polish it to make sure it's at the required standard before it's treated further for direct potable reuse. And the nice thing about this is the whole of the City of Cape Town, everyone will get this water, because they've got a nice integrated network where you can actually switch water from different reservoirs to different areas. They can mix it. So that's what is going to happen. And these direct, this pilot plant that you see in the background that we were using to stress test some of the decisions we were making for the reuse plant downstream was actually 15 MLD in size. So all these stuff that you see here, it was basically temporary equipment. Instead of building reactors, we used steel tanks to deal with that. And we ran it for, I think, 18 months. And we did a whole lot of testing and sent some of the samples overseas when we couldn't test them here. And this has revolutionized, in my view, what the reuse will look like for the future. So before I close, I want to draw maybe to a sense where you can see how clear the effluent that comes from this plant is. You can see it in those glasses. The one on the left, it's actually the mayor of the city of Cape Town, Gordon Hill-Lewis. And that's some of the councillors there. You can see they were happy when they did this, opening of the plant. But I want to just note something. Just because the water is clean, when you look at it with your naked eye, it doesn't mean that it's safe for potable use or non-potable application. Be careful, there can still be hoja bugs in there. But this one, I can vouch for it because we've got all sorts of online monitoring. But to just make sure, because some of the water we use on site for a non-potable application and it comes into contact with the stuff, just to make sure that we do not leave anything to chance. So the little 3 vessels that you see at the bottom in stainless steel there, so those are UV vessels, it's a UV equipment to make sure that the water that is used on site for non-potable application, it's sterilized with the ultraviolet light before they use it. This is the water that comes out of that structure that I said I'll show you how the water looks like. So you can see now from all that water that was in that river that was not good, this is how it looks like. And that at the moment, it's all going into the river because the reuse plant hasn't been built. So this is the 3D renderings of the new reuse plant that will be built to deal with that water. And in my view, this enables resilience through reuse for us. And this plant, it's what I call a beacon of excellence, and it upholds the standard that we've always upheld in South Africa. Before, people will say, you can't come up with a complicated plant that is so heavily automated in the tip of Africa. Guess what? It's working. In fact, some of the people we worked with from Europe on the technology side of membrane, they said, why is this so heavily automated? You don't need this. We said, we need it because the ultimate goal, it's not just at this plant only. There are other things. And they were actually surprised because they say, even in Europe, they don't do the stuff that was done here. To bring it closer to home, we spent about 2 years of design and 6 years of construction on this project. And there were more than 168,000 engineering hours for those that are interested in this. And at the last count, it could be more. It was about 188, technical and advisory staff from Zutari that were involved with the project. And I believe this lays a good foundation for the future because it's been so successful that there are actually similar projects for the city of Cape Town that are actually ongoing now, following on this one. And they are not done by us, which and for me, that's great. So to see that, this belief in this stuff. And like I said, in future, it will be, to be used for cogeneration. So maybe before I answer this question that I asked initially on how should rapidly urbanizing African cities deal with our wastewater while addressing socio-economic issues, I just want to say our team has actually designed something special here, and they came up with a range of innovative solutions, including right now, it is actually the largest membrane bioreactor in South Africa. So the biggest one in Africa is actually in Egypt. So this is the second one. And this has enhanced wastewater quality and reduced, obviously, the footprint that I spoke about. And the upgraded treatment works. It's one of the first steps in the city's plans, as I've alluded, of lower carbon treatment solutions. So the design enables, as you've seen, projects that will offset more than half of the plant's power consumption through combined heat and power in the form of biogas. And also the residue that will come out of that, the plant will be used for agricultural purposes. I believe this project has meaningfully contributed to the city's drive to improve sustainability, which is why we're talking about it today, social equity, economic development, especially in that southeast node of the city of Cape Town. And most obviously, the treated effluent as quality that can benefit thousands and thousands, and it can lead to lifting of, well, it has actually led to the lifting of moratorium on development. And this has unlocked all the development that were required to deal with other things, including public and environmental health, and most importantly, socioeconomic issues by dealing with economic development there. Additionally, the project, I believe, has improved the working condition of the operational staff by giving them something that they look forward to, an office for them, rather than this rundown wastewater treatment plants that you typically will find, especially in the country. And I believe it created meaningful job on site. We've got IT specialists to deal with the IS and IT network that is there, advanced process controllers that are new there, the scientists in that plant, because there's a lab on site dealing with all sorts of things. And I believe that Zutari, together with the city of Cape Town, have gone beyond the initial expectation by transforming Zandvliet wastewater treatment plant from a typical treatment works discharging into a river to a resource recovery facility. For me, this is a factory. It's a resource factory that is well positioned to recover water to improve the city's drought resilient and offset its energy consumption through biogas, which is the next phase that is coming. So this demanded something that was holistic approach to engineering excellence, in my view, and that's why it's won the CESA award, and has resulted in a transformative environmental, social, and economic impact that will stretch for years to come. But most importantly, Zandvliet currently, it's able to treat a population equivalent of 1,000 people from 600 per 1,000, and still it needs to be upgraded to deal with the future load. This vital upgrade ensures that the city of Cape Town can continue to provide essential wastewater treatment services for a growing population and business development in the southeast of Cape Town. It also ensures that the treatment works is able to treat wastewater to standards that have never been seen before, and because the discharge standards actually on this plant are much more than what was required. So in my view, I mentioned the 6 themes that inform anyone in Zutari to design an infrastructure. For us, if I look at the shaping collaborative networks, we've dealt with that by driving sustainability. And if I look at building digital worlds, I can say it's a tick. We've got a live, SCADA monitoring system. And if we look at accelerating equitable quality of life, there's job creation there. There's a moratorium that has been lifted. If I look at creating adaptable infrastructure, we operate that plant in such a flexible manner that it's an abused plant, to be quite honest, with all the demands that it has to meet. And it's also adaptable for future in terms of the reuse. In terms of delivering excellence, I think we've fostered sustainable livelihoods, and the community there, I've got no doubt they will thrive in the future. If I look at enabling responsible production, we're gonna recover all of that water and use it for potable purposes. There's a reduced footprint on that side. And there's long-term financial savings that I showed you in the form of a life cycle costing, OPEX and CAPEX. So if I have to look and say, did we really provide the impact that we wanted to? I say yes, and the answer, simple answer to my exam question is, by providing, by integrating all of these strategies from the technical, sustainability, economic, and social aspects, we were able to build a resilient wastewater system that addresses urgent challenges while promoting sustainability and socioeconomic that is viable for generations and generations to come. What I need to do now is try and play the video. I'm not sure if it will play in conclusion.
For the upgrade, and today we are handing over the membrane technology installation, which really is the heart of this upgrade and makes the capacity more and the quality much better. So this will bring capacity to this catchment, which actually has a moratorium on development. So developments can go ahead, social housing projects can go ahead. All of these knock-on effects are very important.
Yeah, ladies and gentlemen, thanks for affording me a chance to just give you a view of what we did there. And thank you very much for platform, also to CESA for organizing this. I do really appreciate the time that has been given to me to try and share some of the things, and I hope it was just as exciting for you as it's still exciting for me. Thanks very much.
Thanks so much, Mpho. Just want to say that there was a comment in the chat to say it's great to hear how excited you are about your work, and that's really true. Thank you so much for taking the time to present and to teach us all about what you guys did. I just want to say that it's inspirational to see that even though you had all the issues you stated in your presentation, you still had a successful award-winning project. So that is great. Thank you so much. So I have a few questions of my own. So I'll start with a question from my side and give people a chance to type their questions in the Q&A box. So for those of you who don't know, there is a Q&A option on this webinar. So we'll go through as many questions as we can with the time that we have, starting with mine, that's fine. All right. So my first question is, what's the biggest lesson learned, or if you can list a few, with a large project like this, that the rest of us, if we want to tackle a large project like this, what's the biggest lesson learned, so that we can...
I think for me, it's all premised in that question, that we were able to uncover the unarticulated issues from the client without them actually knowing. So we've got a process called design-led thinking. So that process, in answering your question, says you must chuck away all your preconceived ideas and look at the problem in its entirety. So that's why I premised that question, that it wasn't just a wastewater. If you ask yourself a question, is this really a wastewater? Yeah, final solution is you must provide wastewater. But if you go there with an idea that you're going to just design a wastewater treatment plant and leave, it's not going to work. It wouldn't have worked. So one of the things that I didn't mention here is we had a lot of community issues. So that along the way involved us actually seeing that for the city to realize their full potential, they need to employ community liaison officers. Otherwise, the construction mafias take over. But we could have gone there and said, oh, it's an engineering project, so we deal with engineering, it's not our issue. So there's that. The other thing, I mentioned that there were about 188 of us involved, but we had a lot of senior people on site. When I say senior, actually retired people driving this project, and they'd seen stuff back in the day during their time constructing some of ESCOM power plants. So this project, you cannot do it with, young people, well, if I consider myself young, like Mpo that comes up with sophisticated stuff. One of the people that I actually had to convince, it's one of our retired guys. I had to take him through the VR. So in the video that played last night, there's an old man there that has been working for 40 years. So I had to show him through the VR what we're trying to do. And he was so scared because he thought he's going to fall into the reactor. So for those that have never put a VR set, if you have never seen it, it's actually quite something amazing. I'll implore you to do it. But the other thing is, you must never have preconceived ideas. You must never tell yourself that you know more than anyone else, because if you do that, you're never going to succeed. And for us, it was to go beyond the city's immediate need of providing infrastructure for them to collect rates, to understand what the issues were. And we spent a lot of time. We also took our own time to go into some of the surrounding communities there to try and understand what would they like to see. And those things, it's not typically what you will do in an engineering project. But for now, I suppose you have to do that. And what helps us, I didn't come up with those impact themes, those 6 that I explained. What helps us is we are grounded around those impact themes, and they force you to think in a certain way, because we want to see all our projects ticking all those 6 boxes. It's not always possible, but we want all the projects to tick those 6 boxes. So that maybe it's my answer in a long roundabout way, and I hope you understand. So it's not just engineering only that you have to think about.
Thank you so much. So I'm going to take one more. I'll give one more question, and then I'll go to the Q&A box. So my other question was, if you could please elaborate a little bit on how did you ensure minimal disruption to the existing plant while you were busy with the upgrade?
Yeah, so the existing plant, just to put things into perspective, it provided about 64 MLD, provided it was working. But because it was so bad, so to comply with the effluent, it actually needed to be run at like 44 MLD. But the city managed to get some reprieve from DWS and DEDP to continue operating it without actually complying with the effluent quality. In fact, I haven't shown some of the construction pictures. You would have seen what we did. So we kept that plant running as much as it was ailing and not complying with the effluent quality. And when we switched, the first plant to be switched was the MBR plant. But before then, we had to build the primary sedimentation tanks and the inlet works, which are in different places, not where the existing ones were, because the existing ones couldn't cope. So we had that opportunity that we could build a new inlet works, not affected by existing stuff, and then reroute the flow. But at the same time, we built what is called primary sedimentation to reduce the load to the downstream plants. So which meant that the pollution they were causing was actually minimal compared to them. And then when we switched over to the membrane plant has got such redundancies. It's designed for a peak wet weather flow, the new membrane plant MBRB of 81 MLD, or about just 3,750 cubes an hour, in that order. So what we then did, the nice thing about the membrane plant is you can abuse it within resin. So we were able to push the flow so high, under operating scenarios that I spoke about. It's too technical, but I'm happy if someone wants, and I can even explain it. I actually wrote a paper about it, which I'm happy to share. So we did that and increased the flow through the membrane plant, and while we are taking some of the plants offline. So that's what we did. So the first plant to be operated was the membrane bioreactor plant, and we took one of the conventional activated sludge plant offline and fixed that, and then put it back online, took the other one offline, fixed that, and the last was the MBRA plant that was there, to come online, and that happened last year in July. So that's how we dealt with that. We were lucky that we could build a new plant first.
Okay, thank you so much.
But having said that, so one of those 1.8 meter diameter pipelines, when we're diverting the flow, in fact, before we could even divert the flow, when we're building the new intake works, one of the sluice gate actually failed from the existing plant, and there was pandemonium on site. I decided not to show that picture on purpose because it created a dam in about 2 hours. So you can imagine 1.8 meter diameter pipeline flowing full with water everywhere. So it created so much chaos that we were worried that we were going to be in the media for the wrong reasons. But luckily, within a day, the matter was resolved.
Okay.
Thanks.
Thank you so much. All right, so as promised, I'll move forward to the Q&A box. We've got 3 questions so far. So the first one is, does Zutari offer training on this technology?
Yeah, maybe before Marizal, can you read all the questions so that if they are all the same, I can try and cover them in one
Alright.
and give
Alright.
others a chance, yeah.
Okay, I see we got 2 more, so I'm going to read through the rest now. So next one is, what technology did you use for sludge dewatering and why? And then we've got another question asking, with the increased demand for virtual reality and clients really liking visualizations, would you say that the money invested into virtual reality paid out, or would you say it requires some more streamlining before it becomes affordable on smaller projects, smaller scale projects?
Well, let's stop there. Let me try and deal with them before I forget, because I'm not going to make. So the first one is, what was the
Training.
Okay, the training. Yeah, so it depends what type of training you require. But let me explain. We take quite a lot of graduates, and we open up. If you are a graduate, that is, I'm assuming some people are graduates or not, but I'll try and cover both. So we take a lot of graduates, and we've got an internship program in addition to the graduate that employs at least 100 people, and depending on how they fare, some of them stay in the business, some don't. And we're doing that because we realize we've got a responsibility to train young engineers, even if we can't afford all of them, because we take a lot of graduates. But there is another program of 100 graduates to give you a fighting chance if you're looking for work. It would be great if you can work for us, but it's not always possible because of economics. So there's that. So if you're not a graduate and you require training, I'm happy to chat to you offline. My email address is actually quite simple. Can I give it? It's mpo.rampower@zutari.com. So if you email me, provided it's in what we do, it doesn't have to be water related, but please be specific about what you're looking for. If you're not a graduate, then I can take it from there. Somebody asked about the technology that is used and why on the sludge side of it. So we opted to go for gravity bulk thickness and and bulk presses, bulk filter presses. And the reason for that was simple. What I didn't say is we have to deal with a lot of sand in that plant. So there's a lot of wind-blown sand that sits in those process units, reactors, PST, and it's so fine that you can't actually catch it. So before we actually process our sludge, so we've got a sand system where we try and catch some of these sand before it goes into the bulk press, because initially we're finding that our belts on both the gravity bulk thickness and the bulk presses were not lasting the required hours because of the sand. So we've got that system, but still it's so fine that you can't catch it. And the reason we did that, my initial suggestion was to actually go for centrifuges. But centrifuges, we found that, if you know what scrolls are in centrifuges, we found that in Athlone where we had installed them, they didn't last because of the sand. The sand again was an issue that was basically degrading all the equipment quite fast. So we opted to go with the belter filter presses, which meant that we had to build a long building to deal with that. And that's really the main reason why we did that, because we didn't have a fighting chance because of the sand that is there on site. Then there was another question on whether we train people on the technology.
So it was a question on virtual reality. So would you say, oh, yes.
Yeah, so I think it was money well spent. It's not something that you will directly or immediately see the benefit of it when you do it. But trust me, there is no client that is going to pay you. Firstly, I'd like all engineers to stop counting, well, to stop thinking that they have to sell their hours. We count in hours, but the value we provide, it's not in hours. So if you move away from the timesheet mentality, then you'll understand why. Because you have to provide value. I agree, we count in hours for our revenues, but think about the value and the solution that you need to provide for your clients and also for yourself so that you don't deal with the problems. If I take you to that site and you look at the interaction of mechanical, electrical equipment and all the electronics that are there, there is no other way that we could have done it without the use of digital smarts and to make sure that there are no clashes. Even the contractors that have done this stuff before, I put them through the virtual reality. So you can imagine now all of a sudden you don't build wrong stuff. The contractors know exactly what they have to do. They can inform and change certain things and advise you, but from an informed position. So that stuff you're not going to see immediately, but down the line when you're on site, it saves you quite a lot of time. And right now when the city is moving through a digital twin platform, guess what? They've got all the building blocks are there, so they can see the stuff. They're using that also for future generation. They're training their plant operators on site using this virtual reality stuff. And also, kids from schools, they know how the plant works simply because of what we did. I know we didn't get paid for it, but think about the impact that it provides. And in future, we're hoping that as our clients will be able to pay for the value, not the hours that we provide. So that's how I'll answer that question.
Thank you. Right, so we have 3 more questions, and I think let's give it 5 more minutes and see where we're at that point. So I'll read them for you. First one then is there a business case to attract private capital for similar wastewater treatment plant, including biogas power plant and water reuse plant?
Yeah, I mean, I can tell you, so I think firstly, it would be naive to think that the city of Cape Town did fund this project on their own. Okay, it's off their balance sheet because they raise loans and money. But I can tell you, I dealt a lot with a lot of international funders, especially KfW. I know they've provided a loan to a certain aspect of that project, and they'll come to site and have a look and see how this stuff works. And all those multinational funders, what they're interested in is sustainable solutions, whether in the form of reuse or combined heat and power. They want to see that you're thinking about it. I mean, one funder even asked me if I've thought about, precipitation of struvite, as fertilizers, because they're saying if you can do that on a plant of that size, then it's beneficial for the city to start earning income. So the reason they didn't do it, remember, they have to balance this aspect of socioeconomic issues with the immediate need, which is treatment. At the moment, they know that they are paying for electricity. And what I didn't tell you, there is also backup power on that side. And one of the things that we did, because I didn't mention it, is this seamless synchronization of generators when there's power failure. When we started commissioning the plant, we couldn't do it. In fact, it was so disruptive that we had to do what we call prepare the plant for shutdown and wait for load shedding to go and start the plant up, because it was messing up with all those controls and electronic equipment. But last year in October, when we finally got it right, we got equipment, electronic equipment that there's load shedding within 30 seconds, the whole plant, you don't even see anything because the danger of moving a flow, which I didn't tell you, the peak flow on that, it's an Olympic swimming pool in 1 second. It's 450 MLD. Can you imagine that flow in a minute if you don't have working equipment downstream? So we're able to do that to make sure that we can deal with those scenarios. So that's the reason why they didn't go ahead with the biogas for now. So, but they're going with the reuse. That's the only thing that they haven't done. They want to build another 60 MLD and comfortably deal with the flows before they build the biogas plant. And there are 6 generators on that plant, each 1 megawatt to deal with the load. So it's 6 megawatt of power on that side. So you can imagine.
Thank you so much for that answer. I'm gonna move to the next question. Does the reuse pilot plant take log reduction values, LRVs, and contaminants of concerns into consideration?
Yes, actually, I don't know which one would be the right platform. I'm prepared, obviously, with the blessing of the owners, with the City of Cape Town, to actually present, whether it's me or any of my colleagues, I'm not directly involved with the reuse, to present the process train and the CECs and all the testing regimes and everything that you're talking about there, to take you through it and show you all the panel of expert staff from USA, from Australia, that have gone through the rigor that has gone into that process train. I mean, I made a statement in passing, and I said the operative word is the direct potable reuse. It's never been done anywhere else in that scale in the world. So you can imagine that to be able to pull something off like that, you need to have ticked all the boxes. In fact, that pilot plant that I spoke about, it was 15 MLD to deal with this. I mean, there's a huge plant, 15 megaliters a day, that we're just pumping into the environment while we're testing. And I was drinking the water because I saw what was there, because it was safe for consumption. But the real plant that is coming, it's 90 MLD. So all of those things that you mentioned, if we get a platform maybe from CESA or from anyone else, we can present that reuse. But obviously we'll need permission from the City of Cape Town because they haven't built it yet. And it's going through stakeholder engagement for everyone to buy into that. In fact, if you listen to the mayor in some of the clips that they make, they talk a lot about it. I don't know if that answers your question. I know it's a diplomatic way of answering it. But all those CEs and all sorts of corker things you can think of. Yeah.
Okay, thank you so much. I'm sure it answered the question. This person can post a question again if they feel that they have a follow-up question.
Yeah.
Okay, the next one is, please be so kind as to comment or inform us on interest from Africa or the world. Sorry.
That question's a bit vague. It feels to me a bit incomplete. The interest from Africa, from the world, on what?
I think I'm just gonna go to the chat because I feel like I saw a similar question in the chat. So in the chat, this person said, please be so kind as to comment or inform us on interest from elsewhere in Africa. So it's the same question. I think let's ask Alan, this is the person who posted the question, to maybe elaborate on their question. And then that was there's one more question in the chat box, and then I'll go in the Q&A box, then I'll go to the chat box. I think Alan wants to know who is joining the session. Oh, okay. So I think they wanted people in the chat to just post where they're from.
Okay.
Yes. Okay. All right. I see we do have a hand from Asitandile. I think I'll take this one more question and then I'll go to closing remarks. So Asitandile, if you can
I
try.
know who Cherie is. She used to work for us, so I see her there on the
On the chat.
Yeah.
Okay. Asitandile, if you are able to unmute, you are welcome to ask your question. Otherwise, you can post it on the chat. I still see you're muted.
There's someone that says Lucky Masuta from Saudi Arabia. I just wonder if it's the same Lucky that comes from the same area that I was born. So I wonder. Can never assume these days, yeah, because you don't see the faces.
Okay, Asitandile, we cannot hear you, so if you can post your question in the Q&A box, that would be great. I think I need to move over to closing remarks, but you will be able to see the chat box and the Q&A. So if there's any other comments that you want to go through, you are welcome to view the chat box. Yeah, I think we covered all the questions. Let me move over to the key takeaways then, since we want to end at past. So I made some notes, and the most important thing I wanted to note is that through innovative approaches and collaboration, like you said, with your free-for-all meetings, and through successful project management, managing all the issues you've been able to execute an award-winning project. So thank you for showing us that. And I just wanted to comment on it going full circle from a young engineer who won Young Engineer of the Year award in 2011. That would be you, Mpho, to now winning a project. So that is just full circle. Good to see that from CESA's side. And I wanted to ask whether this project has had any commendations on other platforms. And if so, you can share.
Yeah.
Sorry, that was actually the question I wanted to ask.
Yeah, so what we did is we never entered it anywhere else. So we waited, even when we were tempted, we waited up until the last part, which is the MBR A, was refurbished before we can enter it, because it was complete. But what I'll say is we have won CESA awards for the Malmesbury Wastewater Treatment Plant, which was the first successful MBR plant in South Africa. And that was in 2012. So it also won the CESA award, followed by the one in Stellenbosch, also utilizing the same technology. But the solution, it's nuanced, it's slightly different to what we did in Zandvliet. But Zandvliet for us, it's the use of digital smarts that made it all possible. So, I can log into the plant now and irritate the plant operators and change that. Okay, they will know who I am. So, but I can do that. So, and that informs what we do in future, because that data is used for predictive scenarios. Because we're building a machine learning platform in the background as well, to be able to inform what needs to happen.
Thank you. Thank you. So then in closing, just wanted to summarize that this, like you've actually mentioned, this project has covered all the sustainability bases, being environmental sustainability, social equity, and economic development, like you've shown us throughout your whole presentation. So I just wanted to say thank you so much for your time, and thank you for all the attendees and for your questions. I'm sure there are a lot more that people want to see from this project. And then I just wanted to say that it's good to see the digitization, the virtual reality, all of that becoming such a big part of projects like these, because we want to see, like you said, the data live. We want to be able to see right now what's going on. So it's very inspiring to see. And then, we look forward to hearing more from you. And then I want to encourage everyone else listening to actively seek sustainable engineering solutions and to get involved in initiatives promoting the SDGs, because next time maybe we could be showcasing your project. So just keep that in mind. And then from CESA side, I wanted to say that we are hosting another follow-up webinar, so webinar number 2, showcasing a different project. That would be on the 11th of March. And then we also have the CESA infrastructure in Daba on the 18th and 19th of March. So you can be on the lookout for any news on that. And yeah, that is it from my side. Thank you so much for everyone's time.
Thank you very much. I really did enjoy my time with you, and I really do appreciate the platform given to me. Thanks.
Thank you.